All right, boys. Today is a very important lesson because we're talking about roots of real numbers. When we're talking about roots of real numbers, we're talking about radicals. And a lot of you guys know radicals from square roots, okay, or cube roots. But a radical is more than just a second root or a third root. There's an infinite number of different types of roots for a radical. And you have to really understand what you're looking at before you can really solve things. So when you have the radical sign, okay, which is right here, this is the radical sign right here, this guy right here. That's the radical sign. What's inside of the radical, here in blue, is called the radicand. And the number outside of the radical is called the index. If you have no number there, then it's a square root. The 2 for the square root is invisible. It's implied. If it's a third root, I'll have a 3 there. If it's a fourth root, I'll have a 4 there. If it's a seventh root, I'll have a 7 there. But if I have a square root, it's a 2, and it's implied. So, when simplifying radicals, you're looking for sets of the same value equal to the index. Pull these sets out as one of that value. All remainders stay inside of the radical. Okay? Now let me explain what this means. And again, guys, I know I'm going fast, but that's why we're recording this, so you can rewind or fast forward as much as you want. So, based on what I just said here, this is the square root of 25. We all know that it's 5, okay? But let me explain really why. Doesn't this break down into the square root of 5 times the square root of 5? Don't I have 2 of the same value? So I pull every pair in this case out as 1. So the square root of 25 is 5. When I have the square root of 8, the square root of 8, well, I can break that down into the square root of 4 times the square root of 2. And the square root of 4 I can break down into the square root of 2 times the square root of 2. In this case, according to the index, I need sets of blank to pull one out. I need sets of 3. Very good. So don't I have 1, 2, 3 square roots of 2? So the cube root of 8 equals 2. Because I had 1, 2, 3. So I needed 3 to pull one value out. Does that make sense, gentlemen? Yes, sir. Who said no? Okay. What don't you understand, son? Square root of 8 breaks down into, the cube root of 8 breaks down into the cube root of 4 times the cube root of 2. The cube root of 4 breaks down into the cube root of 2 times the cube root of 2. Don't I have 1, 2, 3 cube roots of 2? Am I not looking for sets of 3 to pull one out? So 1, 2, 3 cube roots of 2 comes out as a 2. Now, what about the cube root of 16? Well, here I can break this down to the cube root of 4 times the cube root of 4, which breaks down into the cube root of 2 times the cube root of 2. This one breaks down into the cube root of 2 times the cube root of 2. I need sets of blank to pull one value out. 3. So 1, 2, 3 comes out as a 2. And what's left over? 1 cube root of 2. Not radical 2, but cube root of 2, because we have an index of 3. Yes, sir. If there were 2 2's left over, then that'd be the cube root of 4, sir. Correct, my brother. You multiply the leftovers and you keep them inside the radical. Great question. Thank you. Yes, sir. If there are two, if let's say there was 3 cube roots of 2 and 3 cube roots of 3, well then you pull out a 2 and a 3 and that'd be 6. Thank you, son. Yes, sir.
What's this called when you do the little arrows and then you put...
This is simplifying a radical.
Why do you have to put the radical signs? I've never done that before.
Okay, the question is, why do you put the radical signs here when I'm simplifying? Like here, why do I have all those radical signs? That's just so that I can understand what I'm doing. I'm breaking it down into cube roots, so that way at the end, when I have this cube root of 2, I don't screw up accidentally and put a square root of 2 as the answer, or a fourth root of 2. I keep it as a cube root of 2. If you can organize that in your head, that's fine. Thank you, son. You're welcome. Okay. Now, for simplifying variables, yes, sir. I have no idea what you just said. That's what I was just, they just asked that before, so you need to pay attention. If you had 2 cube roots of 2 left over, then inside the radical here would be cube root of 4. We just answered that question. Thank you. Now, for simplifying variables inside the radical, simply divide the variable exponent by the index. All the leftovers stay inside the radical. So what am I talking about here? I have the cube root of x to the 11th. What's 11 divided by 3? How many times can 3 go into 11 perfectly? 3 times, right? So you pull out x cubed, and what's left over? X squared. Done. What's 11 divided by 3? That goes in. That goes in, and actually, whoever said 3, that's wrong. That is wrong. I apologize about that in video world. That is wrong. 11 divided by 3, guys. That goes in, oh no, yeah, that is 3. Yeah, 3 and 2 left over. My bad. So this is x cubed and the cube root of x squared left over. So divide the index into the variable exponent. Okay. Now, let's make it juicy. No, I'm not going to wait because it's on video. So, what if I tell you the 5th root of 243 x to the 23rd, y to the 7th, z to the 11th? Well, this is easy. The 5th root of 243. I know it right off the bat, but whoop-de-doo for me. Let's figure out how I got that. 243, gentlemen, breaks up into 81, right? Times 3, correct? You can circle the 3 if you want, if it makes your life easier, because you can't go any further than that. 81, you can put them in the 5th radicals. Yes, you're absolutely right. Now 81, that could be broken down into the 5th root of 9 times the 5th root of 9, which can be broken down into the 5th root of 3 and the 5th root of 3. So I can circle this, and I can circle that. And then this one also breaks down into the 5th root of 3 and the 5th root of 3. So how many 5th roots of 3 do I have circled here? So what can I pull out already immediately? 1, 3. Does that make sense? Okay, now, for x to the 23rd, how many times does 5 go into 23? So that's x to the 4th, and what's left over? X cubed. Well done. How many for the y now? How many times does 5 go into 7? So you have a y, and you have a y squared left over. And last but not least, how many times does 5 go into 11? So I have a z squared, and then I have 1z left over. Does that make sense, gentlemen?
Yes. Sir,
Yes, sir.
look at a Z. 2Z.
No, it's z squared. You don't put a 2z out here. You put z squared because a z times a z is a z squared, sir. Does that make sense, boys?
Yes.
Okay. Now, let's look at some radical basics. Okay? I'm going to fill in some stuff here for you that I think is very, very important. No, I'm sorry. I cannot scroll up really quick because I am taping this. So if you need to review something or check something out, you can happily go on Edline and check out the video, sir. So we're gonna talk about this table. On the far left, you have the index, which we call n, and we're gonna talk about what happens if the index is even and if it's odd. Okay? And we're gonna have here the nth root of b if b is greater than 0, and I'm going to have the nth root of b if b is less than 0, and then we have the nth root of b when b equals 0. Okay? So, if it's even, okay, I'm going, and I have b is greater than 0. That means that b is a positive number. And I have an even root. I'm going to have one positive and one negative root. So what that means is if I have the square root of 25, my real answer is plus or minus 5. Now why? Because 5 times 5 is 25. What's negative 5 times negative 5? 25. What if I had the fourth root of 625? This is going to equal plus or minus 25 because positive 25 times positive 25 is 625. And negative 25 times negative 25 is, I'm sorry, it's not 25 if it's the fourth root. It's 5. Sorry. Because 5 times itself 4 times is 625, and negative 5 multiplied times itself 4 times is also 625. Now, if your b is greater than 0, you're dealing with a positive b, but you have an odd root, okay? You're only going to have a positive root. For example, the cube root of 8, that's going to equal 2 and only 2. Because negative 2 times negative 2 times negative 2 is negative 8, not positive 8. Yes, sir. The index is this guy, the n. Okay? Thank you, sir. No, when the index is odd, my brother. Thank you. Now, yes, sir. If the index is not visible, it's implied that it's a 2. Yes, sir. Thank you, sir. Now, if b is less than 0, and you have an even root, there are no real roots. If I have the square root of negative 25, there are no real roots. It doesn't exist. Yes, it's 5i, which we haven't gotten to, but that's not a real root. That's a complex root. So again, the square root of negative 25 does not exist in a real number system. It's no real roots. Now, if I have a negative and it's an odd, then you won't have a positive root, but you will have one negative. For example, if I have the cube root of negative 8, that can equal negative 2 and only negative 2. And if your b is 0, whether it's an even root or an odd root, the answer will be 0. The square root is 0, 0. The 10th root of 0 is 0. The third root of 0 is 0. Does that make sense, gentlemen?
Yes, sir.
Okay. Let us continue then. Now, if I just give you the straight up square root of 25, okay, we know that officially the square root of 25 is plus or minus square root, plus or minus 5. My bad. Now, sometimes though, they're just going to ask you for specific roots. So if they just give you a square root of 25 with no sign in front, that's assuming technically that they want the positive root, that'd be 5. So the negative square root of 25, they want the negative root, which would be negative 5. Now they tell you find the plus or minus square root of 25, it will be plus or minus 5. For my class, Mr. Morrow's class, I will always want plus or minus unless I specifically tell you that I'm looking for a negative. So for my class, if I have on a test or a quiz, find the square root of 64, it's plus or minus 8. Okay? For the cube roots, it's kind of the same thing. If I give you there's only one positive cube root of 8, and that'd be 2. The negative cube root of 8 would be negative 2. But the negative cube root of negative 8 would be positive 2. Because the cube root of negative 8 is negative 2 times a negative is a positive. Now, what if I wanted to solve the following? What would the plus or minus square root of 25x to the fourth be? Plus or minus 5x squared. The fifth root of 32 x to the 15th, y to the 20th. Okay, this is going to be 2x cubed y to the 4th. Five does go evenly into 15. That's why I put x cubed. 5 does go evenly into 20. That's why I put y to the 4th. Now this one right quick would be, this is the square root of y squared to the 8th, correct? So wouldn't this be negative y squared plus 2 to the 4th power? Because what's the index here? 2. What's 8 divided by 2? 4. So it comes out as y squared plus 2 to the 4th power. You with me? All right, boys. Good luck. God bless you. Have a great day.